Okay, welcome back to the Vancast on Monday. So we're going to move on from what we've been learning to a little bit about measurements in the universe. And you can see here, that's the speed of light going around the Earth. That's what we'll look at. And it is a little blob here, isn't it? So it goes, the speed of light is so fast that it would go around the Earth about 7 times in 1 second, 180,000 miles per second, something like that. I have it here. So let's see what we're going to do with this. That's really the main piece of information today. So you guys have been learning about the universe, parts of the universe. So I have here, okay, we've been learning about basic parts. And last week we ended with the 2 main sources of the energy for the super awesome explosions that occur in the universe. Okay? So the 2 forces are the strong nuclear force and the weak nuclear force. These are the forces that hold the insides of atoms together, or elements. Atoms and elements are the same thing. Basic building blocks of our world. So the strong and weak nuclear force require a crazy, awesome, super amount of energy produced from gravity, which produces a crazy, awesome, super amount of heat and pressure on areas of dust and gas or stars and other stuff also in the universe. Okay, so I'm going to first show a little video getting to the middle of an atom. Pretty cool. So this is a journey to the center of an atom from NASA. So we have a hair, and then we get 10 times smaller each time. We're getting 10 times smaller. So there we have hairs, 10 times smaller, and we have just kind of the scales on a hair, not yet down to molecules. And these are the molecules, okay, cells, we're not there yet. Then we get 10 times closer, and you're starting to get to some of the large molecules. Molecules are made of atoms or elements. 10 times smaller, you're getting a better look at the molecule. Now we get a little closer look at the molecule, 10 times smaller, and pretty soon we'll see the elements. Now we're starting to see the parts of the molecule, the atoms, the elements. 10 times smaller, and now we're starting to see individual elements or atoms. Here it says a sulfur atom, here's a nitrogen atom, there's an oxygen atom. 10 times smaller, and there's an atom that we've gone how many times? 10 times smaller, some trillions of times smaller. And this is kind of the energy of electrons in a carbon atom. And the electrons are really energy. Now we're getting deep, 10 times smaller even. We're getting, because this shows you that an atom is mostly empty space, but then we get to the very center of the nucleus. This is the nucleus. So we have protons and neutrons, and the force that keeps this nucleus together, and also the force inside a proton and neutron. These are called quarks. The force that keeps these together, that is the force that we get the energy from for these super awesome explosions in the universe. Is from inside an atom. Pretty darn crazy. Which amazing. It's an amazing video. Okay, so we went all the way from a hair down to the inside of an atom. Pretty cool. All right, so that's that, and so that gives us the explosions in the universe. So it was already taking more time than I wanted. So it's some kind of nice recap of some of these
Of the solar
explosions.
system and the galaxy, we find ourselves confined to an ever smaller corner of creation.
5 minutes, that's okay.
And yet, in this age of Hubble, we
So
have
this
learned
bright
just how
light,
much we are a
either from
product of the
stars
universe.
or from exploding stars or from dying stars or stars being formed.
And of a great
Actually,
cosmic
these are galaxies. These are really more galaxies than stars. Remember, we are a star of hundreds of millions or hundreds of billions, I think it's hundreds of billions of stars in our Milky Way galaxy. So these are all galaxies with also hundreds of billions of stars inside them. Hundreds of millions or hundreds of billions? I can't remember. So it's just crazy, beyond our understanding.
continuum that reaches back to the beginning of time.
So these are all galaxies with hundreds of billions of stars in them. We are part of one galaxy.
In a sense, our own story looms large.
So let's get to the...
When the first stars formed, they began generating oxygen, exploded, generating heavier elements like iron or gold
the
or
source
magnesium.
of this energy comes from the weak and strong nuclear force.
While spreading
Gets
these
squeezed
elements
together
far and
so
wide
much by
in the
gravity.
form of dust.
That the temperature and pressure gets to a point where that proton,
One
the final little
supernova
tiny
was spotted
things I
by
showed you
Chinese
on that,
astronomers in the year
video,
1054 AD.
They actually touch, which is very hard to do. But when that happens,
Astronomers have
you
been
get these
poring over
incredible,
the expanding
crazy, super
cloud
awesome
of gas
massive
and dust,
explosions.
the Crab
Okay, there's a
Nebula.
nebula, right, which is the
What they found
death
is
of
that
a
the
star
filaments of
exploding.
matter that
Well,
roared
actually,
out of the
inside is a
blast
big area,
contain large
usually a
volumes of
remnant
dust,
left over of an exploding dying
an array
star
of
with
mostly
gas and
carbon or
dust.
silicate compounds
Much
that
bigger
absorb
than we
visible
can even
light.
imagine. So our galaxy could have formed in one of these, or our solar system.
These solid particles are crucial for the
Okay,
formation
so
of
that's good, I think. Are we missing any more explosions? Not really. Okay, that's good. So we kind of have a bit of an idea about that stuff now. And now one of the measurements we always hear about is a light year. Okay, so it's the distance light travels in 1 year, which is crazy large distance. So look at this video about speed of light. Where are we? There we go. So I just showed you that briefly. 7 times around the Earth in 1 second. Now they should give you a graphic about the time it takes for light to go one way that we see from the moon. It takes about 1 second. So the light you see from the moon is about 1 second old. The speed at which it's moving. And then I can't manipulate this, I don't think. Can I? And then, if you, from Mars, so 54 million kilometers, about 30 million miles, it takes 3 minutes. So if you ever look at Mars, which it does shine in the night sky, that light is 3 minutes long. So this is showing the distance going in 3 minutes to Mars. So that gives you an idea. The sun, if you're looking at the sun, when you see the light from the sun, that's about 10 minutes old. So light moves crazy, crazy fast. So 30 million miles in 3 minutes. 30 million miles. Okay, so it is very fast. So your assignment today, very simply, is how many miles does light travel in 1 year? So you have to multiply. So it's 1 year. So you have to multiply. We have 365 days times 24 hours. So it's times 24 and 60 minutes in 1 hour. So those are, if you multiplied those three, you'd have how many minutes are in 1 year, which is like 30 million minutes or something. Then how many seconds in a minute? 60. So you multiply those. And then 100,000, 80,000 miles in 1 second. And that gives you how far light travels in 1 year. So you're going to have to do that math. You can go on Google and pop in those numbers, and you should be able to get a number. And that is a light year, which when we're looking at the videos, they're talking about something being 100 million light years away. So it's just well beyond anything we can imagine. The closest star solar system to us, I think, is 2 light years away. One day in the future, we will go visit that, I'm pretty sure. Humans will. Okay, that is all for now. Oh boy, here's the turning off thing again. I always have a problem with this.